Assalamu alaikum friends. Today I would be discussing about the Rankine power cycle. Our first lecture, that is the Rankine power cycle, which is normally used in all the steam turbines and gas turbines, and the principle what it says is explained in the TS diagram. So, Rankine cycle is a vapor and liquid cycle and accepted as the standard for steam power plants. Rankine cycle will be studied in its simplest ideal form to its more complex non-ideal form with modifications and additions that render it one of the most efficient means of generating electricity. Normally, Rankine cycle works in steam power plants and vapor power plants. Normally, steam is used for the generation of electricity as a steam turbine, and other vapors can also be used for electric generation, like organic Rankine cycle. We will discuss later, inshallah. But normally, it is an overview that what Rankine cycle is all about. It is a vapor cycle for generating electricity, any form of vapors. It could be any organic or steam, whatever. So we will discuss the basic principle of Rankine cycle. You can see here is the TS diagram and a schematic diagram. Here we have a boiler. You can see here a boiler. What is a boiler? Boiler is actually a steam generator which converts water into saturated steam. Saturated steam, what it means, a saturated state of vapor. On the TS diagram and the vapor dome of water, and the dome of water here at this curve, as you know mostly that this curve is a saturated vapor curve, and this curve on the left, as I am showing through the arrow, this curve is known as saturated liquid. So what does boiler naturally do? That it only converts water into saturated steam, not into superheated region, only into saturated steam. You can see at point 1 from 4A1, this part takes the place of boiler, in which heat is added and water is converted into steam through the boiler. So when water enters into the boiler, it is normally in room temperatures, or maybe higher than room temperatures, but not at that much higher that it would convert. So what does boiler do? That boiler is a huge shell-like structure that contains tube. Boiler have mainly two types: water tube boiler and fire tube boiler. We will discuss later, but I'm giving just an overview that what is a boiler. So in the tubes, if we have fire, and on the shell side we have water, so by firing furnace oil through the tubes, the water on the shell side get converted into the steam at constant pressure. So at state 1 we can say we are in saturated steam. We have saturated vapor or saturated steam at state 1. From 1 to 2 we have stage turbine, steam turbine, you can say. So this is the amount of work done from state 1 to 2 on TS diagram. And 2 to 3 we have condenser, which takes heat from the steam after exhaust from the turbine. So to cool down that steam, or to recycle that steam or that much amount of water, we use condenser from state 2 to 3. And from 3 to 4 we have pump to take that condensed water to recirculate this water into the boiler. We need a pump over here from 3 to 4. As you can see on TS diagram, that 4A1 is a form of constant pressure line. You can see it's a constant pressure line of boiler. This is the pressure of boiler. So at condenser you have a pressure, you have a constant pressure of heat rejection. Heat rejection is taking place in the condenser at constant pressure. From 2 to 3 we have a lower pressure, and to take that converted steam into water and to circulate that water we need pump from state 3 to 4. And that, what does that pump do? That to increase that to increase the pressure of water, to take it to the boiler again and recycle it for the for further working on it, as it is a cycle. So when you continuously burn out the furnace oil, fuels, or whatever coal you used, the cycle will run and it will give you the amount of generation of electricity. So these are the processes on PV diagram, TS diagram and HS diagram. I will discuss inshallah the whole process on PV diagram, and but the basic is the TS diagram. You must know at least TS diagram of this Rankine cycle. So further discussion is about the performance parameters. That is the basically the efficiency of Rankine cycle. That is efficiency, you all know that output over input, that is the ratio of output to input. So output is our net output, that from state 1 to 2 you can see, let me take it back, from state 1 to 2 there is an enthalpy drop and work is taken from the turbine, but here we have already given a work through pump, that is state 3 to state 4. So we need to minus that pump work from the turbine work and you will get the net work. So net work output is actually the difference of turbine work to the pump work and divided by the input. So what is our input in Rankine cycle? That is heat supplied from state 4 to state 1, that is the enthalpy rise during whole conversion of water into steam at constant pressure in the boiler. So that is our input. So how can we increase the efficiency of Rankine cycle? We can see here clearly, and it is very obvious, that if we decrease the amount of heat supplied from from state 4 to 1, we can see that we can increase the efficiency of the Rankine cycle. So this is all about the basic concepts and the overview of Rankine cycle. In next video inshallah I will clearly explain the detailed parameters that involves in the effect of increasing in the efficiency of Rankine cycle. Thank you.